Okay, here's the key to part 1 of your review. There will not be a video for part 2. I will just have the key to that posted. I'm going to put it in the resource folder in Google Classroom. Okay. All right, so these directions say change the degrees to radians and the radians to degrees. So the intention of this is just a straight up conversion. Now, you could think around the unit circle on this, which I had a few people do. It is okay in this case because because your reference angle here would be 50 degrees. That's not one of our special angles, so just using the conversion is fine, but I'll also talk to you about another way to think about it, and you wouldn't even have to actually multiply. But if we're going to go from degrees to radians, I'm going to multiply by pi over 180. All right, so then I can divide them both by 10. 31 is a prime number, so I'm done, and it is 31 pi over 18. Okay, so now here is kind of a unit circle way to think about it. Since your reference angle is 50, it doesn't really do you much good there, but there's some things that we could think about here. We know that 30 degrees is pi 6. So if I divide them both by 3, I can get 10. And 10 degrees, okay, if I divide this by 3, it's like by multiplying it by 1 over 3, so this would be pi over 18. So 10 degrees is pi 18ths. Well, 310 is 31 times 10. So if I take 31 times this, I get that answer right there. So just different ways to think about it there. All right, so number 2, I'm just going to multiply by pi over 180. You could think around the circle on this one too, you just don't necessarily need to. So both of these I could divide by 5. So 5 goes into negative 155, a negative 31 times. 5 goes into 18, 3 times with 3 left over, so this is 36. 31 is a prime number, so this is negative 31 pi over 36. Okay, so then I'm going to multiply, or I could think around the circle on this. This is 7 pi thirds. So 7 pi thirds puts me in the first quadrant. I've gone 360 degrees and then another 60. Okay, so that's one way to do it. Or I could just convert, and this is 180 over pi. So then the pi's cancel out. 3 goes into 3 once, goes into 180 60 times. So do 7 times 60, and that is 420 degrees. Here I'm going to multiply 180 over pi. So this would definitely be non-calculator questions. Those cancel out. 9 goes into 9 once, goes into 180 20 times. 4 times 20 is 80, so this is a negative 80 degrees. All right, so numbers 7 through 10, these would definitely be calculator questions. So I would take 56, I know it's going to be 56 degrees, right? Then I'm going to take 0.875, I'm going to multiply it by 60, so that's going to give me 52.5, right? So that means that this gives me 52 minutes. Then I take the 0.5 and multiply it by 60, that gives me 30, so then that gives me 30 seconds. Number 8, this is a negative 207 degrees. I'm going to take 0.143, multiply it by 60. That gives me 8.58. So that means I have 8 minutes. I'm going to take the 0.58, multiply it by 60. And that's going to give me 34.8. So this is 34.8 seconds. So to go the other way, I have 16 minutes and 49 seconds, so it's negative 184 point something. So I'm going to need to take 16 and divide it by 60, and I'm going to take 49 and I'm going to divide it by 3600. So you can do each one of those and then you can store them if you want to, but on the calculators that we have, you can set them up as fractions like this, and just let the calculator do it all for you, and you get negative 184.280 degrees. And here, this will be 78 point something. So this will be 37 over 60 plus 3 over 3600. Let the calculator do it all for you, and you get 78.618 degrees. Okay, so then we're back to non-calculator. It's not going to jump back and forth like this on the test. I'll have it separated into sections here. But I want to find the length, so my arc length formula is S equals R theta. I have the radius, I have the angle. So 8.5 is the same thing as 17 over 2. So S is equal to 17 over 2 times 5 pi over 6. So I can't reduce here or here. So I just have to multiply 5 times 17, and I get 85. So it's 85 pi over 12 feet. Okay. Then 12, I need to convert this to radians. So 120 is in the second quadrant. My reference angle is 60. So my 60-degree angle in the second quadrant is 2 pi thirds. So that means that S is equal to 6 times 2 pi thirds. Cancel all that out, and I get S is equal to 4 pi. And that would be inches. Okay, so then to find the area of the sector, my area formula is 1/2 theta r squared. I already have this in radians, so let's just substitute this in. You get 1/2 times 2 pi thirds times 8 squared over 1. So these cancel out, and 3 does not reduce with 8 at all. So my area is going to be 64 pi over 3 miles squared. Okay, number 14. This 300 I need to convert. So 300 would give me the fourth quadrant. My reference angle is 60, so my pi thirds angle in the fourth quadrant is 5 pi thirds. So my area is going to be 1/2 times 5 pi thirds times 12 squared over 1. Okay, so 2 times 3 is 6, right? Well, 12 squared is 12 times 12. So this, instead of being 12 times 12, I can divide a 6 out of it. It's going to end up being 12. It's basically 12 times 2 times 6. That's the same thing as 12 times 12. And that 6 cancels out with that 6. So I just have this 12 times 2 right here. So 2 times 5 is 10, times 12 is 120. So your area is 120 pi centimeters squared. All right, so then we're back to a calculator section. We could set it all up without the calculator, but to get the final answer, we'd have to type that in. So my trig here, my angle, this is the opposite side, this is the adjacent side, so I'm using tangent. So the tangent of 64 is equal to 23 over x. So x equals 23 over the tangent of 64. And that means that x equals 11.218. My angle, so this is the hypotenuse, this is adjacent, that means this is cosine. So the cosine of theta is equal to the adjacent over the hypotenuse. So theta is equal to the cosine inverse of 24 over 37. So theta is equal to 49.560 degrees. My angle, this is the opposite side, this is the hypotenuse, so this is sine. The sine of 22 is equal to the opposite over the hypotenuse, so x equals 19 times the sine of 22, so x equals 7.118. Okay, on the back. 30-foot ladder is leaning against an office building, and the base of the ladder is 17 feet from the base of the building. We're supposed to change that to building so that it makes sense. Find the angle of elevation. All right, so here's the building, here's the ladder, here's the ground. It's a 30-foot ladder. This is 30 feet. It is 17 feet from the base of the building. Angle of elevation, we have to have a horizontal with that, so this is theta. So that means that this is going to be the cosine of theta equals 17 over 30. Theta equals cosine inverse of 17 over 30. So theta is equal to 55.482 degrees. Okay, 23. Sharon is bird watching and spots an eagle in a tree. When she's standing 40 meters from the base of the tree, the angle of elevation from the point at which she's standing is blah, 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 blah. Okay, so here's the tree. Got a little eagle up there. There's my bad little bird. So she's looking at the eagle in the tree. She's standing out here. All right, so here's the ground. So there's Sharon. She spots this eagle right there. Then she moves closer and sees it again. There you go. There are your two triangles. This whole distance right here is 40 meters because she starts out 40 meters away before she moves closer. And then she's got two angle measures, both of which are in degrees, minutes, seconds. We need them in decimals. So this 37 degrees, 27 minutes becomes 37.45. And the 51 degrees, 42 minutes becomes 51.7 degrees. So she starts out here. This is 37.45. And she moves closer, so now this is 51.7. We are looking for how far she moves, so we are looking for this distance right here, which I will call this x. All right, so if I knew what this distance was, I could subtract it from 40 and get this. But in this triangle here, the only thing I have is the angle, so I can't start off that way. But in this big triangle here, I have this side length, which is 40, and I have this angle, so I can find this side right here, which I'll call y. Okay. So then if I can find y, then I can use this triangle here, and this angle, and the side I just found, to give me this side right here, which I'll call z, so that I can then, in the end, find x. And to find x, I'm just going to do 40 minus z. So, let's see. I would start off with this one. So it's opposite and adjacent. So I'm going to have the tangent of 37.45 is equal to the opposite, which is y, over the adjacent, which is 40. So y is equal to 40 times the tangent of 37.45. And that gives me 30.6, blah, blah, blah. And I store that in my calculator. Okay, so then I have that stored as y. I'm looking for z. I can use y in this angle to find z. So the tangent of 51.7 is equal to y over z. And the y is what I have stored in my calculator. So that means that z is equal to y, which is in my calculator, over tangent of 51.7. Okay. So I do that, and I get my z out of that, which is 24.1, blah, 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 blah. And I store that in my calculator. Then I'm going to subtract 40 minus z, and that gives me the 15.804 meters. All right, reference angles. So I gave you reference angles. Now, when we did reference angles in our notes, I gave you things that had fifths and ninths and twelfths and that sort of thing. And it is important to understand that concept. But in the end, what we're really, really using them for are all of our special angles. This should be a piece of cake at this point. If you have any angle, I don't care what the numerator is. If it's reduced all the way and your denominator is 6, your reference angle is pi 6. It's that easy. Here, this is negative. It doesn't matter. Your reference angle is always positive. If this is reduced all the way and your denominator is 3, pi thirds is your reference angle. If this is reduced all the way and 4 is the denominator, pi fourths is your reference angle. Now, remember that reference angles are always acute and always positive. So when we get to number 29, that 3 pi halves, your reference angle is not pi halves. That's not acute. Acute is between 0 and 90. It doesn't include 90. So this doesn't have a reference angle. This is a quadrantal. And what matters is where it is. And this is going to be on the negative y-axis. That's your answer to that one. Okay, so now I'm looking for the exact value of these functions. Okay, so here's where we think around the unit circle, right? And we know that all students take calculus. Okay? So this negative 4 pi thirds. Well, my reference angle is pi thirds. Okay, so I know what the sine of pi thirds is. The sine of pi thirds is the square root of 3 over 2. Now I have to figure out what quadrant this is in and whether or not sine is positive or negative. So if I go a negative 4 pi thirds, this is negative 3 pi thirds, negative 4 pi thirds is right here. So I'm in the second quadrant, and in the second quadrant, sine is positive, so this is my answer. All right, so then I'm looking at secant, right? So secant is the reciprocal of cosine. Okay, so I'll put cosine in parentheses there. So I need cosine of pi 6 because my reference angle is pi 6ths. So the cosine of pi 6 is the square root of 3 over 2. The reciprocal of the square root of 3 over 2 is 2 square root of 3 over 3. Now I need to decide if I'm positive or negative. Negative 7 pi 6, well this is negative 6 pi 6, negative 7 pi 6 puts me in quadrant 2. And in quadrant 2, cosine is negative, so this is a negative 2 square root of 3 over 3. Notice that the angle being negative is not directly related to whether or not your answer is negative. The angle being negative just tells you which way you go around the circle. Okay? All right, so then I have cosine of 7 pi fourths. All right, so that means I need the cosine of pi fourths, which is the square root of 2 over 2. Then I need to figure out what quadrant I'm in. 7 pi fourths, well 8 pi fourths is all the way around, so I'm in the fourth quadrant, and in the fourth quadrant, cosine is positive. So this is my answer. Cotangent of pi 6. Well, cotangent is the reciprocal of tangent. The tangent of pi 6 is the square root of 3 over 3. The reciprocal of that to get cotangent is just the square root of 3. And since this is in the first quadrant, it's positive. So now we are sketching angles and stating their reference angles. So I have 5 pi thirds. Well, 6 pi thirds gets me all the way around. So 5 pi thirds gets me in the fourth quadrant, and pi thirds is 60. So this right here is pi thirds. This right here is 5 pi thirds. So this is my reference angle. 5 pi fourths. Well, 4 pi fourths is here. 5 pi fourths is one more. So I'm right here. So this is 5 pi fourths. And your reference angle is pi fourths. Then I have 4 pi fifths. Even though that's not a special angle, we still know that when we get here, that's 5 pi fifths. So 4 pi fifths backs me up some into the second quadrant. So this is 4 pi fifths, which means it gets me pi fifths more to get to the axis. And that's my reference angle. Okay. So there's part 1 to the review. As I said, part 2 will be just a file in the Google Classroom folder, and everybody should be able to do very well on this test tomorrow. Be ready.